I'll explain this lecture in a very simple way. Click the subscribe button below and watch this unique lecture for free. Types of chemical reactions. The 4 basic types of chemical reactions. I'll make this topic super easy. The first types of chemical reaction is combination reaction. The second one, decomposition reaction. The third one, single displacement reaction. The fourth one is double displacement reaction. Let us start with the first one, combination reaction. When two or more different types of a pure substance react together and form a single displacement, such type of reaction we call it combination reaction. A plus B to form AB. Now, when you look A and B may be compounds, or A and B may be elements, or either A or B is element or compound. But AB is always a compound. Now let me give you different examples for each. Here, calcium oxide and carbon oxide are two different pure compounds. They react together, finally they produce calcium carbonate, which is a compound. The second example, sodium oxide and water. These are two different compounds. They react together to form a single compound known as sodium hydroxide. Sulfur trioxide is a compound, water is a compound. These two different compounds react together, finally they form sulfuric acids. When A and B are elements, example, iron react with sulfur to form iron sulfide. Iron sulfide is a compound, but iron and sulfur is an element. Magnesium is element, oxygen is element. They react together, finally they produce a single compound known as magnesium oxide. Hydrogen is element, chlorine is element. They react together to form a compound, hydrogen chloride. Sulfur dioxide is a compound, oxygen is an element. They react together to form a single compound known as sulfur trioxide. Iron oxide reacts with oxygen to form iron oxide. Here iron oxide is a compound, oxygen is an element, but iron oxide is a compound. Combination reaction, also known as addition reaction, composition reaction, or synthesis reaction. Now the second type of chemical reaction is decomposition reaction, which is exactly the opposite of composition reaction or addition reaction. It involves the breakdown of a single compound into two or more simpler substances. Mathematically, AB breakdown into A and B. Here, AB is always a compound, but A and B may be a compound. A and B may be elements. Either A or B may be element or compound. Let me give you different examples for each. Calcium carbonate, which is a compound. Upon heating, it forms calcium oxide and carbon oxide. Here, calcium oxide and carbon oxide both are compound. Mercury oxide, which is a compound. Upon heating, it produces mercury and oxygen. Here, both are element. Potassium chloride, when we heat it, it produces potassium chloride, which is a compound, and oxygen, which is an element. The third type of chemical reaction known as single displacement reactions. When one element displaces another element from its compound, is called a single displacement reaction. Mathematically, A reacts with BC to form AC plus B. Here, A displaces B and takes the position of B. Finally, AC plus B is formed. Don't forget, A is more active metal than B. Let me give you an example for each. Zinc plus copper sulfate. Here, zinc displaces copper and takes its place, and finally it produces zinc sulfate plus copper. Another example, magnesium reacts with zinc sulfate. Here magnesium displaces zinc and take its place. finally it produces magnesium sulfate plus zinc. The single displacement reaction, also known as replacement reaction. On the other hand, A plus BC equal to BA plus C. Here A displaces C and take its position. Finally, it forms BA plus C. Assume that A is more active non-metal than C. Example: fluorine molecule react with 2 mole of hydrogen chloride. In this reaction, fluorine displaces chlorine and it takes the place of chlorine. Finally, we have hydrogen fluoride plus chlorine molecules. So this one is example of single displacement. Again, second example, chlorine reacts with hydrogen iodide. Chlorine here displaces iodine and form hydrogen chloride plus iodine. But bromine plus hydrogen fluoride, no reaction because bromine cannot displace fluorine. Active metals displace hydrogen from acids. Please stop calling me a zebra. I truly like her calling me a super powerful giraffe. Please, for potassium, symbol K. Stop for sodium, symbol Na. Calling for calcium, symbol Ca. Me for magnesium, symbol Mg. A for aluminum, symbol Al. Zebra for zinc, symbol Zn. I for iron, symbol Fe. Truly for tin, symbol Sn. Like for lead, symbol Pb. Her for hydrogen, symbol H. Calling here for copper, symbol Cu. Me for mercury, symbol Hg. Super for silver, symbol Ag. Powerful for platinum, symbol Pt. Giraffe for gold, symbol Au. And this one is according to their reactivity series: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, mercury, silver, platinum, gold. Metals that's above hydrogen can displace an acid, can displace hydrogen from an acid, but metals that's found below hydrogen cannot displace hydrogen from an acid. For example, zinc, which is found above hydrogen, can displace hydrogen from an acid, therefore zinc chloride plus hydrogen. Copper, which is found below hydrogen, and cannot displace hydrogen from an acid. The fourth and the last types of chemical reaction known as double displacement reactions. Two different types of compounds react together to form another two new different types of compound known as double displacement reactions. AB plus CD. Here A is positive, B is negative. Again seduced. C is positive, D is negative. Therefore, two different charges attract each other. Finally, they form AD. A attracts D, C attracts B, so Cb is formed. Example: silver nitrate plus sodium chloride. Finally, they produce silver chloride plus sodium nitrate. Double displacement reaction only involves the exchange of ions. Double displacement reaction, also known as double replacement reaction or metasis reactions. Thank you.